Hey folks, it's Mr. Woodward talking in this video about key terms when describing motion. We're going to look at four specific terms: position, displacement, velocity, and acceleration, which all happen to be vectors. So first, what is a vector? Well, in physics, especially when talking about motion, we often use measurements that deliberately include direction. These are called vector quantities, okay? So they include direction. So a vector is a quantity that includes both magnitude, how much, that's usually how we're talking about measurements, right? 3 feet or $4 or 50 degrees, that's the magnitude. But then a vector also includes the direction, which is where to. So for example, a position vector would have the magnitude of 10 feet, but also the direction of to the right. And a velocity vector would have the magnitude of 70 miles per hour, but also the direction of north. So here's a helpful visual to really see that a vector is both magnitude and direction. This is a wind speed direction map from windy.com, and it's a map of the San Francisco Bay Area. And so first of all, the colors represent the speed of the wind in different places. So over here on the left, we get this orangish color, which is actually the color for a higher speed. And as we get into the cooler colors here, the green and then the blue, those are lower wind speeds. Okay, so the color is an indication of the magnitude of the wind speed. But then this map also has the direction of the wind, and it's trying to show that through these graphics here, these little white kind of wisps of air. So they're showing where the wind is blowing. So therefore, this map has both wind speed and wind direction, meaning magnitude and direction at the same time. So this is a nice visualization of a vector. So the most common vectors that you will need to understand when discussing the physics of motion are position, displacement, velocity, and acceleration. And so let's start with the first vector called position. And I've got the image of a location on a map, right? Because the simple definition is that position is the location of an object in space, including its direction. And when we're using equations to talk about position, we will use either the variable x or the variable y to delineate the position variables, right? So x would be horizontal position, y would be a vertical position. So a position vector would be something like 14 meters north, or -6 feet, or 87 degrees west of north. And so some of these are positive values, some of them are negative values. A positive value means that the object is located in the positive region, and a negative value means that the object is located in the negative region, okay? So position vector, number one. But then in addition to the position vector, we're going to add a displacement vector. And so this is our second vector. And note that displacement is not the same as distance, okay? Distance is how far you travel, and that's what this line is showing here, how far you travel. But displacement is your change in position, right? So all that matters for displacement is the difference between your starting and your ending place. That's the displacement, okay? So it is independent of the path. So let's take a look at the formal definition. Look at the formal definition. It's just a change in your position. And in equation form, we would use delta x or delta y, where delta x is the final position minus the initial position. That's what we mean here by x final minus x initial. That would be the change in horizontal position. Or you can have a change in vertical position, which would be vertical displacement. That would be y final minus y initial. And then examples of displacement, they end up sounding just like position vectors. So you might have displaced 14 meters north, meaning you changed your position. You moved 14 meters to the north, or you moved 6 feet in the negative direction, or you moved 87 degrees west of north. And so a positive value means that you're moving in the positive direction, whereas a negative value means you're moving in the negative direction, right? Because displacement is actually describing a change in position. So there must have been some sort of movement happening in order for displacement to occur. All right, so we've got position and then displacement. The third vector is velocity. And notice that velocity is not the same as speed. And this picture helps to illustrate that a little bit here. Okay, so a car moving to the right has a speed of 25 meters per second. But a car moving to the left also has a speed of 25 meters per second. So speed is just the magnitude, how fast the car is going. But velocity includes the direction. So a car moving to the right has a velocity of positive 25 meters per second. A car moving to the left has a velocity of negative 25 meters per second. Okay, so a velocity by definition is a change in position over time. In other words, it's the rate of your displacement, how quickly you're getting to where you're going. In equation form, we use the variables v sub x or v sub y. This would be horizontal velocity. This would be vertical velocity. In horizontal velocity, we're interested in the change in horizontal position over time. In vertical velocity, we're interested in the change in vertical position over time. Okay, so change in position over time. Examples of velocity would be something like 8 meters per second to the right, or 37 centimeters per second upwards, or negative 4.6 meters per second. And so when we get these positive and negative values, they now mean for a positive value that you're moving in the positive direction, just like displacement, and that you're moving in the negative direction, just like displacement. Okay, except that they're including the rate at which you're changing your position, right? The time. So we've got meters per second, centimeters per second, meters per second, or you could have like a miles per hour, or a minutes per day or something. Excuse me, not minutes per day. Feet per day would be an example of a velocity.